the last, Mr. Andre Klopper. He's the National FM Manager for Redefine Properties. A person that we actually should be listening to and talking to, an important client to the industry. Mr. Klopper, please come through.
So I've got the special section, which is the one for lunch, and 10 minutes to go. So I realize it's standing between you and a possible cold beer. I hope you don't need to go and work on the equipment go off. So I get the nice part as well from the presentation. You've seen some of the previous speakers talk about the Internet of Things, mechanical things. So I get to talk about the airy-fairy things that could be's, the can be's, and the possibles. I'm going to go through it fairly quickly. As you can see, back then, I'm pretty sure if you're in the lift industry, you remember this picture. You see it quite often in the head offices of the lift companies across the world. So now, about 162 years later, this is the Aquadome in Berlin, in Germany. A lift actually going up and down between a fish tank, which I think should be quite interesting and keep people going up and down the lift. You might have a guy in the lift for about 2 trips, I would guess. That is just to show you how technology have changed in about 162 years. So what I'm going to talk to you about today is the artificial intelligence and the effect that have on our built environment. So what does it look like? It starts with big data, which lays the foundation for artificial intelligence. And then it goes on with all the aspects there on the left-hand side. You can see familiar terms: deep learning, predictive analytics, translation, classification, and so the list goes on. And then you end up with 7 branches of AI, which you can see is machine learning, natural language processing, speech, vision, expert systems, planning, scheduling and organizing, and robotics. Those are the 7 main branches that makes up AI in the built environment. So what we're going to do today is we're just going to look at one of those branches, which essentially is the one that goes from big data to predictive analytics, machine learning, and ultimately gives you artificial intelligence, which is a theory. I also think that this is possibly the most promising branch of artificial intelligence for the built environment, not just pertaining to lifts, but in general. So let's look at the things that affects this. So in mega trends, and I need to just take a little bit of a sideways step, and you need to just bear with me very quickly. The future doesn't just happen. There's various factors that either encourage innovation or hamper innovation, and therefore progress. These trends, to a large extent, is driven by the ability of countries to encourage and enable the public and private sectors to innovate, produce, sell, and sell in the marketplace. So essentially, you need a political will to achieve these things. And if you look at the mega trends, they're listed there, and I'm just going to touch on 3 of them very quickly. Economic growth. I think we see a move in the world economic in an easterly direction, and I suspect that is going to continue for the foreseeable future. Globalization is something that is very high on the agenda, because if you're moving into the realm of artificial intelligence, making sure you keep the best workforce and employ the best workforce becomes a real challenge. And then lastly, technology developments. Technology progress with increased productivity leads to new industries, and that is key in influencing these mega trends. Now let's talk about big data. We've heard about guys talking about big data, and if you are technology disabled as I am, I until last week thought Facebook was something you get from exclusive books. My wife had to take me for coffee and explain it's on the internet. Big data is a field that analyze systematically and extract information from otherwise big data sets that are too large or complex to be dealt with by traditional data processing and application software. And that's the first step. Big data is everything we can collect from the built environment. But big data has got a caveat to it. Not all information can be used in big data. Data with many cases or rows offer greater statistical power, while data with higher complexity, in other words, columns, may lead to higher false discovery rates. So it's not just data per se. The data needs to be cleaned, categorized, and sorted for it to be worthwhile. So how big is big data? I thought that was a very good way of trying to explain how big big data really is. You can see Facebook, in 1 internet minute, 60 seconds, 1 million people log in, 18.1 million texts sent, 4.5 YouTube videos viewed, and so the list goes on. Tinder, never heard of that. You can see, if you go through this internet minute, that it is a whole lot of information that is gathered. And that's, in a certain way, represent what big data is. So what is big data and facilities management? It is data sets that are growing rapidly. And it's growing rapidly because there's relatively inexpensive sensing devices, Internet of Things devices. It's becoming a lot more cost effective. You can install it in more things, we can track more things, and thus collect more information and therefore make more informed decisions. You've heard of the Internet of Things. There's terms like the building Internet of Things, the mechanical Internet of Things, and then cloud-based computing. Those are key concepts in what forms big data. So where is big data collected from? It's from lifts, from pumps, HVAC systems, power usage, water consumption, and sustainability. Now, originally, big data was associated with three main concepts: volume, veracity, and velocity. And recently, they added a fourth one, which is veracity. In other words, how much noise is in that data? How clean is your data? So nowadays, us as facilities managers are actually after the data that these service providers previously collected and used as part of their service structures. So let's look at machine learning and predictive maintenance. Predictive maintenance, I think you would agree with me, is possibly the holy grail in the maintenance industry. If the Deputy Director General up front knew that the lift wasn't working, she would have left 10 minutes earlier and take the stairs and would be on time and not rush. But predictive maintenance is a key thing. You want to get to things before they break down. And this is where the next branch of artificial intelligence comes in, which is predictive analysis and machine learning. So what is machine learning? Machine learning algorithms build a mathematical model based on sample data known as training data in order to make predictions or decisions about without explicitly being programmed to perform the task. So it relies on patterns in data to learn the possible outcomes. Machine learning algorithms are used in applications such as lifts, and we've seen from the previous presentation from Schindler that they do using it. And for that matter, all the big lift companies are sitting with similar products at the moment. So what is training data? Training data is data that have been tagged, it's categorized and sorted. So new enterprises with algorithms as a service and other products will emerge. I think this is one thing that is key that we need to understand, that somebody like Redefine, who does not have the size of portfolio that the Department of Public Works have, but we have per capita a lot more lifts, sit with a whole lot of information about how those lifts perform in different environments, which I'm pretty sure is information that the larger lift companies would like to have their hands on. And we're absolutely willing to share it with them, at a cost, of course. So let's move on to the next one, of the benefits of predictive maintenance. It reduces consumption, it reduces labor cost, it is proactive, thus reducing operational cost, and it monitors performance. Predictive maintenance relies on the actual condition of equipment rather than the average or expected life statistics. Now I want to give you an example here. Generators being one of those pieces of equipment. If you look at the life cycle of generators, we all service them, if you're a facilities manager, religiously once a quarter. What we're saying with predictive maintenance is service the equipment once the condition of the equipment deteriorates within certain parameters. And that might mean you start servicing it only once or twice a year. If you don't have a lot of load shedding, why service the equipment if it's not working? And that is the holy grail of predictive maintenance, which we try in facilities management by reducing the operational cost. So we get to the interesting part, which is artificial intelligence. It's the last thing. Now, artificial intelligence, I think it's very important to understand as a concept. It's not something you can touch, not something you can feel. You can experience outcome from that. But it is a concept. And all these different aspects that we've touched on all contributes to this concept of artificial intelligence. Now, it's interesting to note that within artificial intelligence, you get two types of artificial intelligence. You get weak artificial intelligence and you get strong artificial intelligence. Let's look at strong artificial intelligence. It is when presented with an unfamiliar task, a strong artificial intelligence system is able to find a solution without human intervention. Weak artificial intelligence is a system that is designed to deal with a particular task and process. So it's also important to understand that the two types of artificial intelligence that you might encounter, that you use the right application in the right environment. So artificial intelligence in the FM environment, for us the two key technologies is machine learning. In FM, machine learning will assist in greater application of self-monitoring technologies, proactive and anticipatory facilities interventions, and better data-driven interventions. From a building information management system, computers will be fed with rules, instructions, to develop a design with a building optimal footprint, structural load capacity, and thermal performance. So in other words, bespoke requirements to that building. And in particular, where we find that in buildings that were older buildings that were designed for a lower ratio of person per square meter and suddenly have to deal with double that load, this becomes a very, very important and strong tool to use. So I believe there's very few industries where the interaction between machines and humans will be as close as within the facilities management industry. So this is the airy-fairy part. Where is all of this going in the future? I think in future, with all of this, we're going to see more careers. And that's careers that's not just going to affect facilities management. You're going to see it across the board in anybody who's got to do with something in the built environment. We're going to find career profiles such as system anthropologists, studying the various aspects of humans within past and present societies, as well as within virtual systems and AI. 3D material experts, someone who are an expert in the field of choosing the correct material to print 3D parts or tools for equipment. And I just want to stand still with that one for a quick minute. I remember somebody saying, one of the previous speakers, they had to wait 6 to 8 weeks for a specific part. I had that very same experience, and out of desperation went on to Alibaba, and I'm not going to mention names, but it was one of the big service companies in our country. And I took the CEO a bet that I could have a specific lift button to him by the next morning, which was a bit of ambiguous, I must be honest. But I somehow got onto Alibaba. I found the exact same button we need, and lo and behold, before 12 the next day, it was on that CEO's desk delivered. So the 6 to 8 week waiting process can be a significant less. From the 3D printing, and I can also speak from personal experience, we actually have printed 3D parts for fountain heads and so forth. So that is a very real aspect already in facilities management. Avatar relationships, people who manage the interaction between technology and humans, especially in the realm of artificial intelligence. I would give anything to be a fly against the wall when HR needs to sit there with somebody who's got an issue with a computer who made a different decision than a human. Very quickly, transitionists, those who can help transitions happen, maximizers, optimizers, data contextualists, and failure point assessors. So the new generation have a vastly different outlook and requirements than us older generations. They're more inquisitive, they want to experiment with, which leads to innovation. So what is the future built environment going to look like? I suspect we're going to look at transplantation in buildings, not just vertical, but horizontal, and possible in a circular motion. I think we all have seen this picture of Mr. Elon Musk's plans for Mars. And I guess there's also a lot of movement of people and equipment, especially in taking the gravitational environment that you're based in. It's going to be a lot more difficult to move larger pieces of equipment. This one from a very well-known movie, Elysium, moving people up and down in circles and across, are all aspects of the future. So, in a very straightforward way for somebody like me, I think it's something like this. Up and downs in lifts is probably going to be something of the past, and something like Pac-Man, which I was very familiar with, is possibly the way the future is going to look like. So it's going to be more bespoke solutions. We're going to see developments such as training data companies emerge. I think data will become an asset on the balance sheet, and a whole new economy where information is a commodity develop. And last but least, I couldn't resist, and this was about 1 o'clock this morning. I had a spurt of creativity. I thought everybody's going to talk about what is the fastest elevator out there, which one goes the highest, which one goes the furthest, and all those good things. So I thought I'll bring you the fun factory. Because if you're the national facilities manager, as I do, you get to spend a lot of time in lifts, and it's quite interesting to see people's reaction. So I Googled, true, a couple of suggestions that I want to put out to you today when you go into the next lift. First is take a bit of chalk with you and draw a square on the floor. And when somebody walks into the lift, tell them, listen, you've marked off your personal space. They're not allowed to interact with you. When you're in a full lift, say to yourself, oh, no, not that, motion sickness, especially if the lift is full, and see what happens. Thirdly, stare at your fellow passengers and say out loud, I have new socks on. Fourthly, sing Mary Had a Little Lamb while you push all the buttons from floor 25 down to the basement. And then lastly, I want to suggest, say, I wondered what this is for, and then press the red bell button just before your stop is due. Thank you very much, ladies and gentlemen.